Check one. Check one. Check one. Check one. Check one. Right. Good evening, everybody. Back again with our essay night session. Now, today we have to complete the seventh essay question. That is your physics essay. Bio essay is done. That is your fifth essay is done. Sixth essay, chemistry is already done. And today we have to discuss our physics essay. Before we start, confirm me from your end. Can you all hear me properly and see the board clearly? Yes. YouTube. Yes. 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 All good. All good. Right. Today is 10th. 10th is almost like over. We have 2 more hours to finish today. That means you are going to your last 1 week count. Last 1 week count and another 7 days. Yes, by this time you are done with your first exam. I'll talk a little bit about the exam and start the session today. Because I know the level you are in, the stress level you are in, the scare or the fear you are in. So I'll talk about that and start the session now. Actually, this fear, this stress, everything will last until you start your first exam. On the first exam day, 8 o'clock you have the exam. By 8:30, all this fear that builds up, all this stress that builds up will fade off. Only until the first half an hour, until the first half an hour of the exam, you will have the stress. That was only for the first exam. After the first exam onwards, after that, when you continuously do the third, second, third, fourth exam, there is no fear. So now don't take this fear that you have for the exam as a reason to not work. I am scared for the exam. There is a fear building up in my exam, building up inside me for this exam. Due to that fear, I'm not going to study. This time, the fear that you are having, that is going to fade off just within the first 30 minutes of your first exam. So why you are not working now for something that fades off in the first 30 minutes of the first exam itself? Don't waste this last 7 days because of that fear. So tell it to yourself. You should motivate it to yourself. No, this is an unnecessary fear I have. This is a useless fear I have. If I keep on having this fear, this is going to waste my remaining time period that I have to go for my best result. Tell it to yourself and start working. Think how much of minutes you wasted today just because of that fear. I won't tell hours. I hope that most of you worked today. But there may be minutes of miss or minutes of wastage today because of the fear or thinking what will happen to you in the exam. Why you are wasting it? Don't do it now. Now, final 7 days. Don't make reasons to waste your time and get a low result. You have this time, last 7 days. Now I don't tell you can't go for the best result. Even if you're in your W levels, yes, you can go for your A within the last 7 days. Ekat, I have talked already about how to work like ghost, how to work like robots. Now we have to work like that. Final 7 days, don't get distracted. Keep your focus. Keep your laser focus only onto this. Only onto this. This is your final 7 days of the 11 years of race. Final 7 days. Last bit you are running now. Now you should have your maximum endurance. Now you should have your maximum power. Put the maximum into this. Whatever it comes after this, it's your result. So put your maximum and finish it off. Don't finish it in a normal way. So don't make fear, stress, depression, those things a reason to fail this exam or go for a low result. Eva reasons never. Don't make those results as a kind of a shield around you. Don't do that now. Right? Fear you will have, stress you will have, maybe depression you will have. All those things will last only until the first exam, first 30 minutes. After that, everything will fade off. Right? So don't keep it as a reason now. Now, if you get a fear, if you get stressed, if you get depressed, if you start thinking that I have a lot of things to work, a lot of things to finish off and work now, tell to yourself, for the last 7 days, if I keep on thinking about this, I'll waste so much of time. Tell it to yourself and start working. Hurry. I have told you, instant working here. Now, if you feel like where to start, what to start, when what time to start, what times to start now, today, what time to start studying, I have told you. At that moment itself, stop whatever you're doing, take a book, start studying something. Science science again, something you start studying. Within the next 5 minutes, you start studying. After you start your engine, after that you will keep on working. You'll keep on working. Hurry, right. I'll start the session. Physics questions are there for us to discuss. Yeah, 2024. No, 2023. 23. We have to discuss 2023. Yes. 2023 physics, 2023 physics, 2021 physics, and 2019 physics to discuss. Right? Is there any audio issue? No. No. No issue. I'm looking at the Zoom one. There's no this thing. Sorry, I'm looking at the YouTube stream. No issue with the sound there. It can you all won't have any issue. Hurry, right, we'll start. 2023. This is 2023. This is 2023 O level physics. Hurry. Now, once when you do the 3 questions, you will understand the physics pattern as well. There's nothing big here. Right. Question 7A. 7th one is physics. These are all selection questions. A student mass 40 kilogram. Now, in physics questions, even in physics night, I told you, if they talk about any quantities values, please make it a point to highlight it and keep, or extract the data and keep, because most of the time at the end, they will ask you to use an equation and find out something. For that, you need this data. A student of mass 40 kilogram, staying at a lower level in the school premises, climbs up a flight of steps in 1.5 meters. When you start reading this teacher, we should understand what concept in physics they are talking. Mass is given, height is given. Most of the time, MGH question, it might be, or work done question. Gravitational potential energy or work done question. Height and enters a building at a higher level. Right. Question number 1. How much is the increase in the potential energy? This is Increase in the potential energy of the student who reached the higher level from the lower level, assuming G is equal to 10. Right? They're asking gravitational potential energy. Mass is 40, height is 1.5. Dingle apply the equation. 7th on A Roman 1. Gravitational potential energy is equal to mgh. In physics question, write the equation and start. Some students directly start writing the values there. No. As a question, write equation and start working. Gravitational potential energy is mgh. Mass of that fellow is how much? 40 kilogram. Mass is 40 kilogram. He's climbing a staircase of height 1.5 meter. Radiational potential energy is 10 ms to the power minus 10. How much? 600. 600 joules. That's the gravitational potential energy. These are nothing big. Did I start with the wrong paper? Only me, not make. 2024 this 2024 O level paper yeah, 2024 level paper. This 2024. Hari command ne karla dam. I'll do this and start 2023. Right? God do with me. Right? How are physics no? Roman 2 2024. Right. Roman 2. How much is the amount of work done by the student here? What's the amount of work done by the student here? What's the amount of work done? Roman 2, they are asking the work done. Everything is equation. Work done, what is the equation? Work done, what is the equation? Force into distance moved in the direction of force. Work done is force into distance moved in the direction of force. Now, if you are climbing up a staircase, this is a famous question. You are climbing up a staircase. Your mass is 40 kilograms. Your mass is 40 kilograms. If your mass is 40 kilogram, then your weight is going to be 400 Newton. If your weight is 400 Newton, this 2024, if your weight is 400 Newton, how much is the upward force you need to apply to climb? Your weight is 400 Newton, what should be upward force? Upward force also should be 400 Newton. Remember, when you're climbing up staircase, you apply a upward force equal to your weight. When you're climbing up a staircase, you apply a upward force equal to your weight. Your weight is 400 Newton and your upward force also should be 400 Newton. So the force is 400 Newton. He's climbing up a staircase of height 1.5 meter. So there also you get 600 joules. Harine, 600 joules is the work done to gain this potential energy. He is doing 600 joules of work to gain this potential energy. So at the top position, his potential energy will be 600 joules. Why? In the staircase, he is doing a work of 600 joules. Roman 3. If the student took 4 seconds to climb, the steps, what is the power of the student in climbing these steps? What is the power? What is the power? Power. You have to start thinking on the equation. Power. What's the equation for power? Power is equal to work done divided by time. Work done is 600 joules. He is taking how much of time to climb that staircase? He is taking 4 seconds to climb the staircase. He is taking 4 seconds to climb the staircase. Divide by 4 seconds. So if I do the math there, 600 divided by 4, 150 watt. The power. What? What? This paper do with me. We are discussing 2024 O level. 24, not 23. This 2024 last O level. Hurry. Right. Next question. Yeah, I'll be going fast because there are 4 papers to discuss today and you all also don't have much of time. Without the question that you can't understand, you all look at the discussion. Other questions you all keep doing. Go fast. B part A. B part. A uniform wooden block of mass 1 kg is kept at rest on a rough horizontal table as shown in figure 1. This is on a rough horizontal table. Roman 1A. Under how many forces does the wooden block stay at equilibrium? Right. I'll first mark the forces there so it's easy to understand. Lamai, when an object is at rest, what are the forces going to act there? Guaranteed from the object, from the center of gravity downwards, you will have the weight of the object. There will be weight acting downwards. Now to balance the weight, there should be a force acting up. The force acting up to balance the weight is perpendicular reaction force. You call it perpendicular reaction because it is acting perpendicular to the surface. It is acting perpendicular to the surface. And how you draw these forces? Remember, your weight force acts from center of gravity downwards. Reaction acts in the same line of action from the surface upward. So from here to here weight, from here to there perpendicular reaction. Now that's not the question. They are asking under how many forces does the wooden block stay at equilibrium? How many forces are contributing for equilibrium? 2 forces are contributing to equilibrium. B part, name what are those forces? Weight, perpendicular reaction. Weight, perpendicular reaction. Tell me another name for perpendicular reaction. Normal force or normal reaction force. C part, copy the figure above in your answer script and mark those forces. Done. Make sure when you are marking these forces, both the forces are in the same line of action. Not in 2 different line of action. Same line of action. D part, what is the magnitude of each of the forces? Now weight force we can tell. They have told the mass, no? Mass is 1 kilogram now. Directly weight is 10 Newton. If the weight is 10 Newton, downward force 10 Newton, if to balance it, upward force, perpendicular reaction also should be 10 Newton. Roman 2, another identical wooden block is kept on above wooden block as shown in the figure 2. On top of this, another block is kept. A part of the instances shown in the figure 1 and 2, in which instance is the limiting frictional force between the surface of the table and the wooden block is greater? Out of this instance and this instance, in which one limiting frictional force is greater? Remember, limiting frictional force increases when the perpendicular reaction also increases. Limiting friction increase when perpendicular reaction increase, and perpendicular reaction increases when the weight increases. Limiting friction increase when perpendicular reaction increase. Perpendicular reaction increase when weight increase. Out of these two, in which one weight is greater? Second one. In which one perpendicular reaction is greater? Second one. In which one limiting friction is greater? Second one. Figure 2. B part, explain the reason for your answer for part 2A above. What's the reason? Perpendicular reaction is greater in second instance. Therefore, no, limiting friction is great. Perpendicular reaction is greater in second instance. Perpendicular reaction is greater in second instance. Therefore, limiting friction is greater. Therefore, limiting friction is greater. Therefore, limiting friction is greater. See what? More simple. Almost like 15 marks is there. Nothing up to here, whatever the questions we did, there is no physics. I will tell there is no physics there. Nothing to think. Direct questions. 2024 last year O-level paper. C part. AC and CB shown in the figure are two rectilinear, again straight line roads. AC, CB are straight roads, sorry. Their lengths are 220 meters and 500 meters respectively. The shortest distance between the places A and B is 600 meters. This is the shortest, this is the route. A motor car starts from the state of rest at A, moves along the road AC, CB and comes to rest at B. From rest goes rest. Starting from rest goes to Z, from C, A and goes to B, right. It took 120 seconds for this motion. Time is given 120 seconds. Hurry. Time is 120 seconds. Taking the motion of the car into consideration, calculate the following. The distance traveled by the car, Lamai, what is distance? Total length of the path of the motion. Total length of the path of the motion. Path of the motion is ACCB. Total length is 500 meters plus 220 meters. That is 720 meters. 500 plus 220, 720 meters. Problem 2. Average speed of the car. Average speed of the car. Physics. Again, equation. Average speed. Speed is equal to average speed. No, they are asking. I'll write the full equation for average speed. Average speed. Average speed. What's the equation? Average speed is total distance divided by total time. Total distance is 720 meters. What's the total time taken, it seems? What's the total time taken, it seems? 120 seconds. Total time 120 seconds. If you do the math, how much? 6 meters per second. Hurry. Roman 3, displacement of the car. What is displacement? Shortest possible linear length between the starting point and the finishing point. Shortest possible linear length between starting point and finishing point is displacement. Starting point A, finishing point B, shortest possible linear length. Shortest possible linear length is 600 meters. Make sure in physics, even in chemistry, when you're writing those answers, you write the proper unit. Then Samarlamai just, they write 600 and come. No, wrong. 600 meters. Recheck your unit properly. Problem 4, average velocity of the car. Average velocity. How do you calculate average velocity? Average velocity is total displacement divided by total time. Now, total displacement we got it as 600. Total displacement we got as 600 meters. 600 meters. Time lama, it's the same time. We calculate the velocity for the same time, 120 seconds. When you do the math there, 5 meters per second. Onna lamai 20 marks. 20 marks is there. Any doubts? Yeah, for such simple question, yes, more simple question, 20 marks. Hurry. More simple question. 2024 batch is very lucky. Try their sixth question and see. That sixth question became a bit tough. I think we discussed. I don't know whether we discussed or not. Their sixth question was a bit tough. That's how that's what you call as selecting your question in essay. Some question, now this question with discussion, I almost finished it in 15 minutes. So you maybe if you're fast enough, you can finish it in 12 minutes. Right? You can finish it about 12 minutes. Hurry. This was not in our plan. This is 2024 O level. This was not in our plan. Now, if you tried it for the first time, maybe you would have tried it for the first time with me. Now you know your original marks there. Original standard of doing the physics question there. Hurry. Now we'll start our normal work. Our work plan is actually 2023. This is the original question we have to discuss. 2023 question. Right. Now this is common. Usually they ask about geometrical optics here. They can talk about power equation, power equal energy into time, or Q equals mc theta equation can come. Recently there is part about motion in straight line. Now even 2024 motion in straight line, easy question was given. Displacement, distance kind of question. Here also motion in straight line is given. Hurry, we'll start. 7th on. A Roman 1. When a coin placed on the bottom of a vessel containing water is viewed from top, the coin appears as if it is raised above the bottom. Copy figure 1 in your answer script and draw the ray diagram which shows how the coin appears raised like that. When you put a coin inside water, due to refraction, that coin will be appearing as if it is risen. The image will be slightly above the original object. They're asking you to draw ray diagram and show how the coin appears risen. This is 2023 O level. Question 1, A Roman 1. They're asking you to draw ray diagram and show how the coin appears risen. One lesson, simple ray diagram is there. Catch this part. That is water. Let's take inside water. There is a coin. Outside is air. Inside water, there is a coin. Coin is somewhere there. Really, you have a coin there. The object is really there. Really, you have a coin. Believe me. Really, you have a coin there. When you look from outside, you won't see the original position of the coin. You will see as if the coin is risen. They're asking you to draw a ray diagram and show how it appears risen. Right. How it appears risen. This is what you do. These are the steps. Listen to me very carefully. From the coin, keep a ruler, draw a dotted line perpendicularly up. From the coin, keep a ruler, draw a dotted line perpendicularly up. Step 2. That's your first step. That is dotted line. Step 2. From the coin, take one light ray towards the surface of the water. That's a light ray coming. That's a light ray. May dotted line light ray anyway. Yeah? This is a light ray. Now for us to see the coin, first of all, light ray should come from the coin to our eye. For us to see the coin, first of all, light ray should come from the coin to our eye. So I'm doing one light ray out. Now light ray is coming from water to air. From water to air. That is our separating surface. That is our separating surface. Go. That's the separating surface. Right. Now, water to air, denser to rare medium. What happens to the light ray? Light ray bends towards the normal, the away from normal. The denser to rare, towards or away. Towards or away. Light ray bends away. So, make the light ray bend away from normal. Now, this is the original light ray. Bend it away from normal. On. I bent it away. Bend the light ray away from normal. So the light ray coming from the coin reaches your eye somewhere there. Light ray coming from the coin reaches your eye somewhere there. Now where is the image of the coin is formed? Simple. After drawing this, again keep the ruler on the refracted ray. Listen to the words I'm using and what I'm doing. Keep the ruler on the refracted ray and draw a dotted line backwards, extending the refracted ray. Extending the refracted ray, draw a dotted line backwards. There will be a point where the previous dotted line and this dotted line meet. Meeting point, image of the coin is formed. Meeting point, image of the coin is formed. So originally coin is here, its lifted position is here. When you look from here, what you see is the image. That means what you will see is this. Again, how did I draw? From the coin, a dotted line up. Next, to see an object, first of all, light ray should come from the object to our eye. Object is inside the water. So from water, I am drawing a light ray. But the problem is when light ray come from water to air, it will bend, it will refract. Where will it bend? Towards the normal, the away from normal, the away from normal. So I refracted it back. I refracted it. Away from normal, I refracted it. Now, when you're looking at it, this light ray, you extend it backwards. There is a point where the previous dotted line, this dotted line meet. That's the point where image is formed. Hurry, got it? Hurry. Yes. Hurry. Hurry. Perfect. Take a screenshot and keep. In case if you didn't draw it, I can't give long time for you to draw because your time is limited. Everyone's time is limited. So what is that? A. A is air. Write it fully and keep. A is the air. W is water. Alright. Roman 2. Now this exact question won't come for your O level. Exactly this they will ask you to do. But it in an integrated way they can ask. In a little different way they can ask. That's why we are discussing these things. Roman 2. Figure 2 below illustrates 3 instances of the incident angle in the denser medium of a light ray traveling from denser medium to rarer medium. Instance X, incident ray is smaller than critical angle, incident ray is equal to the critical angle, incident ray is greater than the critical angle, right? We'll discuss about critical angle. Even in the final seminar, I discussed about critical angle. Because critical angle is usually a question that can come for your essay 7. Critical angle refraction question, right? Dingala will again revise the critical angle section. The same thing I discussed in final seminar as well. Critical angle, right? where we discuss about critical angle. Where we discuss about critical angle. We discuss about critical angle when light ray travels from denser medium to rarer medium. When light ray travels from denser to rarer, we discuss about critical angle. Only denser to rarer, we discuss about critical angle. Rarer to denser, never. Right. Now let's take a light ray travels from denser medium to rarer medium. Onna listen, ne? Let's take a light ray travels from denser medium to rarer medium. From denser to rarer, a light ray is traveling. Lamai, when light ray travels from denser to rarer, what happens to the light ray? Light ray bends away from the normal. Light ray bends away from the normal. This is the angle of incidence. This is the angle of refraction. Remember, light ray bends away from the normal. This is normal refraction. This normal refraction take place. This normal refraction take place when the incident angle is less than the critical angle. When incident angle is less than the critical angle, this normal refraction take place. Light ray bends away from the normal and goes like that. Now let's take our incident angle is I is equal to the critical angle. When I is equal to the critical angle, critical refraction take place. What happens in critical refraction? Or a refracted ray goes along the separating surface. Refracted ray goes along the separating surface. This ray goes along the separating surface. Refracted ray goes along the separating surface. This is critical refraction. When I is equal to the critical angle, refracted ray goes along the separating surface. At that moment, at that instance, angle of refraction is equal to 90 degrees. At that moment, your angle of refraction R is equal to 90 degrees. Let's take now angle of incidence is greater than critical angle. When angle of incidence is greater than critical angle, what will happen? When angle of incidence is greater than critical angle, what will happen? Now, total internal internal reflection take place. Now total internal reflection take place. Ek light ray is coming. I value is greater than the critical angle. As I value is greater than the critical angle, refracted ray, it won't refract and go. It will reflect and go. That ray will reflect and go. You call it total internal reflection. Total internal reflection. At this moment, I value and R value become equal. Harani reflection is taking place. Incident angle, reflected angle become equal. So simply keep in mind, when I is less than critical angle, normal refraction will take place. Light ray bends away from the normal and goes. When I is equal to critical angle, critical refraction take place. That means refracted ray goes through the separating surface. At that instance, R value is equal to 90 degrees. When I is greater than critical angle, total internal reflection take place. Light ray comes, it will reflect and go. Right. So the question asking, what is meant by critical angle? What's the meaning of the word critical angle? What is critical angle? What is critical angle? You can define it in two ways. One, when light ray travels from denser medium to rarer medium, and angle of refraction is 90 degrees, angle of incidence is equal to critical angle. One way of defining. Again, see, don't go to memorize these things. Understand it. When light ray travels from denser medium to rarer medium, and angle of refraction is 90 degrees, angle of incidence is called critical angle. One definition. Another definition, when light ray travels from denser medium to rarer medium and refracted ray travels along the separating surface, angle of incidence is called critical angle. When light ray travels from denser to rarer and refracted ray goes along the separating surface, angle of incidence is called critical angle. So what are the two definitions? Simply put it in mind. When light ray travels from denser to rarer, R value is 90, I value equal critical angle. One definition. Two, when light ray travels from denser to rarer and refracted ray goes along the separating surface, angle of incidence is called critical angle. Well, I'll tell one definition properly, write it and keep, write down. When light ray travels from, when light ray travels from when light ray travels from denser medium to rarer medium, denser medium to rarer medium, denser medium to rarer medium, comma, an angle of refraction is 90 degrees, an angle of refraction is 90 degrees, and angle of refraction is 90 degrees, comma, angle of incidence is called critical angle. Angle of incidence is called critical angle. Angle of incidence is called critical angle. Alright. Second definition, I will just tell and keep. If you want, you can write a short note and keep. When light ray travels from denser medium to rarer medium and refracted ray goes through the separating surface. Separating surface is the interface. Refracted ray goes through the interface. Angle of incidence is called critical angle. Hot. B bar. Copy figure 2, that is this, in your answer script and complete the ray diagram instance X, Y, Z indicating the continuous path of the light. This one even in a rapid revision session I did. X, incident angle is smaller than critical angle. I is smaller than critical angle. What will happen? Normal refraction will take place. Y, incident angle is equal to critical angle. I is equal to critical angle. Refracted ray goes along the separating surface. That's the interface. Z, incident angle is greater than critical angle. I is greater than critical angle. Total internal reflection takes place. C part, name the phenomenon occurring in Z, figure 2. Z, figure 2 is total internal reflection. You all write fully, you can't write TIR. Total internal reflection. Reflection. Some students write as refraction. Lamayo, make a refraction. Neveini. Go. Make a refraction. Neveini. This is reflection. Total internal reflection. D part, give example of two occasions in which phenomenon stated in above is made use of. What are the places where total internal reflection is used? One, in optical fiber. This is used in optical fiber. Where is optical fiber used? Even you can write that separately. Where is optical fiber used? In endoscope. In telecommunication. You can write internet connection. Where else? In right angle glass prism. Right angle glass prism. in a polished diamond, all those places total internal reflection take place. Sorry, they're asking only two. B what? The time taken for boiling a quantity of water required to prepare 4 cups of tea using an electric kettle, which indicated that its power is 1000 watt, is 3 minutes. Those are important points I'm underlining and keeping. The time taken for boiling a quantity of water required to prepare 4 cups of tea. You are preparing 4 cups of tea using an electric kettle, which indicates the power is 1000 watt. Power of that kettle is 1000 watt and it is working for 3 minutes. All right. For 3 minutes, you are boiling water in a kettle of power 1000 watt. From that, you are preparing 4 cups of tea. Right. Roman 1. Calculate the amount of electric energy spent here. Power you know, time you know, they are asking energy. Power you know, time you know, they are asking energy. How do you calculate the energy? How do you calculate the energy? Power you know, time you know, energy. What's the equation? Energy E equal PT. Energy equal power into time. These equation, don't forget, guaranteed in 7th essay question. You might know, most of the time there is chance of getting equal PT type questions. Energy question, energy power connection question, there is much chance of getting it in the 7th essay. E equal PT. Power, as I can remember, 1000 watt. Time 3 minutes. Lama, you all tell me, in physics questions, can we write the time in minutes? No, we have to write it in SI unit. What's the SI unit for time? Seconds. 3 minutes, how many seconds? 3 minutes, how many seconds? 1 minute, 60 seconds, and 3 minutes, 180 seconds. From there, your energy is going to be 180 000 joules. You can keep it like this, you'll get full marks, or even you can keep it in kilojoules. Kilojoules. What do you mean by kilo? Kilo is 1000. So instead of writing 180,000 joules, I can write 180 kilojoules. Both are correct. Roman 2. How much is that amount of electrical energy in kilowatt hour? More question. And they are given it in bracket. 1 kilowatt hour is 3.6 into 10 to the power 6 joule. 1 kilowatt hour is 3.6 into 10 to the power 6 joule. They are asking how much is this in kilowatt hour, and they have given a hint for us, which means using that hint only you do the question. That's why they are giving a hint. Something is given in the bracket means they are asking, hey, look at that bracket, I have given you a hint. Using that you do the question. That's the expectation. So hint is given. What's the hint given? 1 kilowatt hour is equal to 3.6 into 10 to the power 6 joule. This is the hint given. This is given. This is given. What are they asking? Write this value in kilowatt hour. So I have the joules value. I have this side, 180,000 joules I have. They are asking how much is that in kilowatt hour. How much is that in kilowatt hour? I'll write a symbol for that. P. They're asking P. P is how much is that in kilowatt hour. How much is this in kilowatt hour? How do you do these types of questions in science and maths? One relationship given, one relationship asked. One given, one asked. Now what you do in science and maths? You divide this side, that is 1 kilowatt hour, divide by power, equalize it to division of that side, 3.6 into 10 to the power 6 joule, divide by 180,000 joules. That's how you do these types of question. One relationship given, one relationship asked. Now you divide this side, equalize it to the other side. Harne in maths you would have got those questions. Right? Amal and Kamal goes to the fruit shop and buy 180 mangoes for 3,000 rupees. How much is one mango? 180 mango, 3,000 rupees. One relationship given. How much is one mango? One mango they are asking. One relationship given, one question, one relationship they're asking, how you do the question. What is given, you divide it by what is asked. Or same type question. One given, 1 kilowatt hour, 3.662. How much is 180,000 joule? Now do the math. Now some fellows are more scared when they see these kinds of numbers. This number, this number. What is this? They are given it in scientific notation. If you are not that good in maths, convert it into the normal numerical number you know and solve it. If you are good in maths, convert this into scientific notation and do. I'll convert this into scientific notation and do. We'll convert this into scientific notation. How you convert it into scientific notation? These steps you don't need to show, but as different types of students are here, your thinking patterns are different. I have to cover up all of you all. Eka, I'm showing these steps. 180,000 joules converted into scientific notation. In scientific notation, only one digit should be there before the decimal. So 1.8, I can write 1.8 into 10 to the power 1, 2, 3, 4, 5. 5 joules. 10 to the power 5 joules. Now at least one or two fellows will ask, sir, why 10 to the power 5 joule? Why 10 to the power 5 joule? I have kept a decimal here. Then after that, how many digits are there? 1, 2, 3, 4, 5. That's why 10 to the power 5 joule. Eva maths, eh? I'm teaching all those things because I know you all don't know sometimes these things. 10 to the power 5 joules. Now do the math. If I need to find power, I should subject power. Power goes up, this goes up, this goes down. Power is equal to 1.8 into 10 to the power 5 divided by 3.6 into 10 to the power 6. That is equal to 10 to the power 5 I can fully cancel off. 10 to the power 6 I can cancel off. Therefore, 10 to the power 1 will remain at the bottom. 10 to the power 5 I can fully cancel off. 10 to the power 5, 10 to the power 6. This I can fully cancel off. This will get cancelled off. Then only 10 to the power 1 will remain in the denominator. So that is 1.8 divided by 3.6 into 10 to the power 1. Now if I do the math there, 1.8 divided by 3.6 is going to be 0.5. 0.5 divided by 10 is going to be 0.05. 0.05 kilowatt hour. That's your answer. No need to write all these steps. You can go to this step directly. Right? But I'm doing all these steps because I need to solve your maths doubts as well. Different types of students are there. No? Or otherwise, some fellows will quickly tell why these kinds of steps directly from here you can go to there. Yes, we can go. As a teacher, I can go. But this is not the time for me to show my colors here. I need to show all the steps. Hurry. So 3.6 into 10 to the power 6 joule divided by 180,000 joule. If you want, you convert this into a normal digit. That is 3650. 3650. 60 never. 3650. I thought you cancel the zeros and do. That is one method. Otherwise, convert this into scientific notation. 180,000. That is 1.8 into 10 to the power 5. 10 to the power 6, 10 to the power 5 cancel off. 10 to the power 1 is remaining. So when you convert this, P goes up, this goes up, this goes down, you will get 0.05 kilowatt hour. Hot. Don't make mistakes in maths. That is maths, and the remaining part is maths. Roman 3. Woku superior question. Ne? How much is the amount of electrical energy wasted in kilowatt hour if an amount of water required to prepare 8 cups of tea was boiled to prepare 4 cups of tea? I did this question once in rapid revision. The biggest mistake that students do is they don't understand this question. Again, read it. How much is the amount of electrical energy wasted in kilowatt hour? They are asking a wastage here. If an amount of water required to prepare 8 cups of tea was boiled to prepare only 4 cups of tea. Right. What they are asking is a wastage. If an amount of water required to prepare 8 cup of tea was boiled to prepare only 4 cup of tea, which that means they are asking how much is the power, how much is the electrical energy wasted in kilowatt hour. You are using electrical energy that is needed to prepare only 4 cup of tea, and you are preparing that water, you are using that energy for 8 cup of tea. How much is the energy wasted? If you prepare 4 cup of tea using the energy that can be used to prepare 8 cup of tea. I think in physics night also I did this question. How much is the wastage if you use the energy that is needed to prepare 8 cup of tea is used only to prepare 4 cup of tea. Using the energy for 8, you are preparing only 4. That means there is a waste. They are asking the waste. How to do this question? Right. First, we'll calculate how much is the energy used for 8 cup of tea. How much is the energy used for 8 cup of tea? But using that energy, what you are doing? You are preparing only 4 cup of tea. We'll calculate how much is the energy used for 8 cup of tea. We'll calculate how much is the energy used for 4 cup of tea. If you subtract it, you can calculate the wastage. Energy used for 8 minus energy used for 4. You can subtract it, you can calculate the wastage. We'll calculate how much is the energy used for 8 cup of tea. See, we already got 0.05 kilowatt hour. This energy is used to prepare how many cups of tea? You are calculating that value for how many cups of tea? That value was for 4 cup of tea. For 4 cup of tea, you know the energy value. For 4 cup of tea, you know the energy value. I'll write E4. For 4 cup of tea, you know the energy value. How much? 0.05 kilowatt hour. එහෙනම් ළමයි, how much is the energy for 8 cup of tea? 4 cup of tea, you know 0.05 kilowatt hour නම් 8 cup of tea should be 2 into 0.05 kilowatt hour. හරිනේ mathematically? 4 cup of tea this value නම් 8 cup of tea should be twice of it. Which means 8 cup of tea energy value is 0.1 kilowatt hour. That is 8 cup of tea energy value. And you already know the energy for 4 cup of tea. 4 cup of tea energy, you know, 4 cup of tea energy is 0.05 kilowatt hour. That we already calculate. 4 cup of tea is 0.05 kilowatt hour. Now the question is asking, if you use this much of energy to only prepare 4 cup of tea, then what's the wastage? You're using this much lot of energy and preparing only 4 cup of tea, then what's the wastage? How to calculate the waste here? Simple. You're using this much of energy. E8 you are using to prepare only 4 cup of tea. E4 is the cup of tea you're preparing. So that minus that, you will get the waste. You're using this much of energy and preparing only this. Now that minus that, you will get your wastage. E8 is 0.1 kilowatt hour minus E4 is 0.05 kilowatt hour. If you subtract it, your wastage is going to be 0.05 kilowatt hour. Hurry. Hurry. I discussed in physics night. Yes. Hurry. Right. See what? When a motor car runs with a uniform speed, 10 meters per second. Hurry. On a rectilinear road. Already we discussed about this word rectilinear. Previous question was rectilinear means straight road, linear road. The driver of the car sees a barrier placed at a distance of 4 meters. These are important data. In this instance, he applies the brake to avoid an accident. The time that elapses from the moment of deciding that brakes be applied to putting the application of brake into effect That is his reaction time is 0.2 second. Right. Problem 1, find the distance traveled by the car during the time 0.2 second. What is this 0.2 second? That's the reaction time. What do you mean by reaction time? After you see something, for you to take the decision and apply the decision, it takes a certain time. You see, you receive the input. For you to take the decision, give the output, there will be a time taken. That's your reaction time. Now you see something happening in front while you are driving. For you to see, take the decision, apply the decision. For example, let's take there is a barrier. For you to see the barrier, take the decision, apply the brake. For that, there will be a certain time taken. That is your reaction time. Now here, this person's reaction time is given 0.2 seconds. They are asking, find the distance traveled by the car during that 0.2 second time. What's the speed of the car? Speed is given 10 meters per second. Speed is given 10 meters per second. Time is given 0.2 second. Can't you find out the distance he traveled? Speed you know 10 meters per second. Time you know 0.2 second. Can't we find the distance? Yes. What's the equation? Speed is equal to distance divided by time. Anay sir, you told me don't use this equation neither. Yes, don't use this equation if there are different types of motion. Use this equation for uniform speed motion. You can use this equation for uniform speed. Use this only for uniform speed. Only for uniform speed questions, use this equation. For any other speed type question, don't use this equation. You use the graph to get the answers. Here, uniform speed question is given. He is uniformly traveling with 10 meters per second speed. So, uniform speed question, you can use this equation. Otherwise, don't use this equation. Speed, you know, time, you know, distance you need to find. Then subject distance. Distance is equal to speed into time. Speed is 10 meters per second. Time is 0.2 second. If I do the math, they are 2 meters. So during his reaction time, he's traveling a distance of 2 meters. Roman 2. The retardation applied by the brakes was 40 meters per square second. Retardation is the deceleration. It's a negative acceleration. And the distance traveled under the retardation till the car stopped was 1.25 meters. Even when you apply the brake, the car travels a certain distance. You call it the braking distance. Braking distance is 1.25 meters. Question A, could the driver avoid the accident? Now again go through the question. When a motor car runs with uniform speed on a rectilinear road, the driver of the car sees a barrier at a distance 4 meter. There is a barrier at 4 meter distance. In this, he applies the brakes to avoid the accident. Time taken to take the decision and apply that 0.2 second. So he sees the barrier 4 meter. Reaction time is 0.2 second. During this 0.2 second reaction time, he is already traveling 2 meters. And then only he applies the brake. After the reaction time, only brake is applied. His braking distance is 1.25 meter. Braking distance, I'll write BD. Braking distance is 1.255 meter. They're asking, could the driver avoid the accident? We'll calculate. Barrier distance is 4 meters. His distance traveled during reaction. Reaction time is 2 meter. Braking distance is 1.25 meter. Can he avoid the distance? Total distance traveled. 2 meter plus 1.25 meter is the total distance traveled. That is 3.25 meter. This is the total distance he is traveling after he sees the barrier. Barrier is at 4 meter distance. He can avoid or cannot avoid? Can avoid. Why? His total distance is less than the distance between him and the barrier. This is 3.25, that is 4 meters. So can avoid. B part, if the mass of the car was 1000 kilogram What is the force applied by the brake? They are asking about force means only one equation is there, F is equal to ma. I think don't think of anything else in physics. Mass of the car and him is given 1000. Deceleration is given. Deceleration is a negative acceleration. So negative acceleration is given 40 ms to the power minus 2. We can find the force. So if I apply the equation there, F is equal to ma, mass is 1000 kilogram, negative acceleration 40 ms to the power minus 2. If I do the math there, 40,000 Newton. That's the braking force. 40,000 Newton. See what? Explain by a calculation whether the accident could have been avoided by applying the above force in an instance where reaction time is 0.3 seconds. Now the reaction time is 0.3 seconds of a driver who was sleepy or under the influence of liquor. Now another person, that fellow, his reaction time is 0.3 second it seems. If the reaction time is 0.3 second, we'll calculate the reaction distance. We'll calculate the reaction distance. Speed is equal to distance over time. Distance is equal to speed into time. His speed, no changes, 10 meters per second. Time is now, his reaction time is now 0.3 second. Now the reaction distance is 3 meters. Reaction distance is equal, it's itself coming 3 meters. And what is his braking distance? BD. Braking distance, no change again, 1.25 meters. Reaction distance 3 meters, braking distance 1.25 meters. What's the total distance? Now the total distance is equal to the reaction distance 3 meters plus the braking distance 1.25 meters. Altogether how many meters? 4.25 meters. More than the barrier distance. If it is more than the barrier distance, he can avoid or cannot avoid? Cannot avoid. Goes and get chug blasted there. Alright. So he cannot avoid. Cannot avoid the accident. Will get chug blasted. Are? Are? That's it, Neil. That's it, 2023 O level. Now, compared to 2024 7th question, 23 7th question is a bit tough. I would tell about 10% tough again. Compared to the previous question, this question 10% again. 10% again tough. Right? That's why question selection is important. Just because 2024 6th 7th question was easy doesn't mean the previous year question is also easy. Next is what 2021. We have discussed 2021. Here is 2021. This. Oh, not this paper. Oh no, 7th question. Now you can understand. Can you see again? Optics part is given. What is it? Optics part is given. Again, optics part is given. or energy part is given. Kettle question. Energy part is given. So here also there's a pattern. Right. Seventh question. The diagram shows this 2021. Right. The diagram shows how a ray of light coming through air falls on a block of glass. That ray of light travels through the glass block and emerges into air again. Air to glass to air. We'll draw the ray diagram and keep guaranteed. See, first question they're asking ray diagram. Draw the rough sketch of the complete path of the light ray on your answer script. Right. Air to glass to air. It can rarer to denser to rarer. Rarer to denser to rarer. Rarer, denser, rarer. This is air. This is glass. Back again, light ray comes to air. We'll draw the light ray. We'll draw the light ray. Right. Light ray is coming in air and it is going to glass. Air to glass, rarer to denser. Rarer to denser, what will happen? Light ray bends towards the normal. I think previous question we discussed denser to rarer. Denser to rarer away from normal. Rarer to denser towards the normal. So instead of light ray going straight like that, it bends towards. It bends towards the normal. It bends towards the normal. Light ray bends towards. And again comes to a interface here. Glass air interface. Again there is a separating surface. So again you draw the normal line. Now again light ray bends. Glass to air. Again light ray has to refract. It has to bend. Glass to air. Glass to air. Glass to air is denser to rarer. Denser to rarer towards the away. Denser to rarer towards the away. That we discussed already. And make sure that this ray and this ray are parallel. Why? This ray is also coming in air. This ray is also traveling in air. So both are in air. So make sure that both are parallel. Both are parallel. We'll name the rays. We'll name the rays. What is this ray? That is the incident ray. What is this ray? That is the refracted ray. What is this ray? That is the emergent ray. That's the emergent ray. What are the angles? This is the angle of incident. That is the angle of refraction. This is the angle of emergence. Here, this angle, we don't give a special name to that, but mathematically we can give a value to that. What can you tell about this value and this value? Mathematical, think maths. What can we tell about this value and this value? Both become equal. Both become equal. This value become equal. I.e., this is the normal line. That is the other normal line. Can you see a Z is formed? Letter Z is formed. If letter Z is formed, this angle and this angle become equal. What is it called as? Alternate angle. Alternate angle. So those two are alternate angle. Automatically they both become equal, which means if this is R, this also becomes R. That also becomes R. Right. I value is given already 30 degrees. Roman 2. In the sketch, mark the angle of refraction R relevant to the first refraction of the ray. Now, if I properly mark the angles, I value is already given. I value is 30 degrees. R is this R and this R become equal. Those are the angles. Roman 3. Write the equation which shows the relationship between angle of incident and angle of refraction. Consider the refractive index of the glass with respect to AR is n lambda u. Even the hint is given. They are given refractive index is this. They are asking a relationship between I and R. What's the relationship between I and R that connects with refractive index? That connects with refractive index. Refractive index, simple n is equal to sine I divided by sine R. Refractive index, simple n is equal to sine I divided by sine R. Roman 4. What is the value of the angle of emergence of the light ray? Lambda. Look here very carefully. See, I told you incident ray and emergent ray are parallel. These two are parallel. If these two are parallel, what can you tell about these two angles? Mathematically think. If these two are parallel, what can we tell about these two angles? They become equal. These two are parallel now, automatically these two angles become equal. If those two angles become equal, emergent angle value will be how much? How much? 30 degrees. 30 degrees. Emergent angle will be 30 degrees. Roman 5. Following diagram indicates how light ray traveling from denser medium to a rarer medium falls on the interface. Sorry. A part. What is the path of the refracted ray when the angle of incident theta in the denser medium is equal to critical? My repeat question. They are telling when angle of incident I is equal to critical angle. What is the path of the refracted ray? Only tell me when I is equal to C, what will happen? What kind of phenomenon will take place? Critical refraction, which means your refracted ray goes like that. Now can you understand the pattern of the questions? The same thing that we discussed. Hurry. B part. B part. By what name is the phenomenon happening known when the angle of incident in the denser medium is greater than critical angle? When I is greater than the critical angle. What is phenomenon called as? When I is greater than critical angle, you call it what? Total internal reflection. You have to write it fully. May what short form karande pa. Total internal what? Reflection. Don't make mistakes. Total internal reflection. C part. Write to example for the instances where phenomenon in B above is made use of. What are the places where total internal reflection is used? In optical fiber, in right angle glass prism, and in polished diamond. Optical fiber, right angle glass prism, polished fiber. Hurry. B part. Water of mass 1 kilogram. Mass is given. Water of mass 1 kilogram is contained in an electric kettle used in a house. Roman 1. What is the amount of heat required? Q value they are asking to raise the temperature of 1 kilogram, mass is given, of water from 20 degrees Celsius to 100 degrees Celsius. 20 to 100. Specific heat capacity of water is 4200. Right. B part, Roman 1. They're asking what is the amount of heat required for a water of mass 1 kilogram to raise the temperature from 20 to 100. From 20 initial temperature 20 to 100 final temperature 100. Specific heat capacity given. What's the equation? What's the equation? Q equal mc theta. M value given 1 kilogram. Keep in mind M value should be written in kilograms. Sometimes they'll give it in grams. Don't get confused. You should write it in kilograms. M value is given 1 kilogram multiplied by specific heat capacity is given. Specific heat capacity of water is 4200 joules per kilogram per degree Celsius. That you multiplied by theta. Theta is the temperature change. 20 to 100, what's the temperature change there? 20 to 100 temperature change is 80. From there, your Q value is 80 into 4200, 8 into 42. Three, three, six. How many zeros? Triple zero. 336 triple zero joules. Give me this value in kilojoules. They are not asking in kilojoules. In case if they ask, you should know. Or already one question I told you. Give that in kilojoules. Don't think a lot. Kilo means 1000. 1000 means 3 zeros. Cancel off 3 zeros. If you cancel off 3 zeros, 336 kilojoules. That's your kilojoule. Hurry. Makeup another one I wanted. Some lazy fellows are there. They don't write these steps properly. Remember, physics question, you have to write the equation. You have to substitute the values properly. You have to get the final answer. For all those steps, you have marks. ඒකට පෙන්නන්න ඕනි කියලා I took the marking of this question and kept to show you all how you get the marks. Check the marking. Can you see that Q equals mc theta question? Go. Q equals mc theta for the equation. For the equation, for the equation, there is 1 mark. For substitution, there is 1 mark. For answer with the unit, there is 1 mark. So equation you have to write. It's a must for you to write 1 mark. Substitution, again 1 mark. See how they are substituted? With units you have to substitute. For answer with unit, 1 mark. Hinda, don't ignore these steps. Don't ignore the steps there. Ignoring steps is a big mistake you all do. Don't ignore any steps when doing these types of questions. Hurry. Which means exactly these 3 steps you have to do to get your full 3 marks. Another question is asking, sir, when we are substituting, should we substitute with the unit? Yes. Look at the marking scheme. The marking scheme. Look at the marking scheme. With the unit only, they are substitute. Remember, if you write like this, even some teachers teach like this. If you write like this, you have written some numbers. We don't discuss about numbers in physics. Numbers we discuss in maths. In physics, we talk about physical quantities. What you have to write is quantities. Mass is a quantity. Quantity has a value and a unit for sure. It might have a direction, it might not have a direction. Those are basics. So when you are substituting for quantity, you have to indicate the unit as well. If it is temperature, you have to mention it, Celsius, the Kelvin. If it is specific heat capacity, you have to mention what it is. If it is mass, you have to mention what it is. That is the correct way of doing physics. Sometimes in some marking, maybe they will give marks only if you write the number. Sometimes. Habai, correct way of doing a physics question is you write the units together with the number. That is a physical quantity. So do it in this way. Losing marks for those kinds of things, useless for gain. You know the concept, you know how to get the answer. Happy just because of the steps you're losing marks. That's something that you're really losing. No, don't do that. Problem 2. Find the amount of heat absorbed by the kettle and now kettle. Previous one is water, neither. Previous one is water, now kettle. Amount of heat absorbed by the kettle when temperature of the water in the kettle was increased from 20 to 100. Temperature is increased from 20 to 100. That means Roman 2, theta is 80 degrees Celsius. No change there. Hurry nothing. When water is boiling from 20 to 100, kettle also will heat up from 20 to 100. Heat capacity of the kettle is 160 joule per degree Celsius. Again read, again read, again read. They are given it in bold letters. Heat capacity 160. Heat capacity is given. Specific heat capacity never. Heat capacity is given. What is the symbol for heat capacity in physics night? I taught you. What is the symbol for heat capacity? Simple C in a way. Simple C is specific heat capacity. Heat capacity equation, the symbol is capital C. Heat capacity is 160 joules per degree Celsius. Joules per degree Celsius. Now you will ask, mass is not given. Without mass, how to do this question? Printing mistake. Nah, you don't need mass for this. Can you remember in physics night I taught you all a relationship between specific heat capacity and heat capacity? Capital C simple C equation relationship I taught you. What's the relationship between heat capacity? Heat capacity, capital C is heat capacity. That is what they have given in this question. Capital C is heat capacity and simple C is specific heat capacity. Specific heat capacity. What's the relationship between capital C and simple C? Heat capacity and specific heat capacity. Remember, heat capacity is equal to mass into specific heat capacity. Heat capacity is equal to mass into specific heat capacity. Capital C equal MC. That equation, that relationship, keep in mind. Right. Now they have given theta value. They have given heat capacity and they are asking to calculate the heat change. What's the usual equation we use for heat change? Heat change Q is equal to MC theta. Heat change is MC theta. Only sir, M value is not given. No? Hurry, think M value is not given. M is not there. Hurry. Even specific heat capacity is not there. No? Hurry, A is not there. Now how to do this question? Lamai, see. We already know MC is equal to capital C. We already know that. MC is equal to capital C. Using equation 1, I can tell Q is equal to MC is equal to capital C. MC is equal to capital C. Instead of MC, I put capital C. Theta. Agree? Instead of MC, I put capital C. Do I have capital C now? Do I have the capital C given? Yes. 160. Do I have theta? Yes. Now can I do this question? Yes. So remember, if they give heat capacity, capital C, they won't give you M. M is not needed. Why? MC is equal to capital C. M mass into specific heat capacity is already equal to heat capacity. Now why they need to give mass? They won't give mass. So don't get stuck in this question. Basic equation to calculate heat capacity is Q equals MC theta. But if they give heat capacity, they won't give MC. Why? MC is equal to capital C. Got it? So now if I write the values, Q is equal to capital C. Capital C is 160 joules per degree Celsius. Theta is 80 degrees Celsius. How much? 16 into 8. 1, 2, 8. How many zeros? 2 zeros. 12,800 joules. Got. Got. Right. Roman 3. Power of the heating coil used to heat the kettle is 1000 watt. Now, Lamai, usually in these types of question, they will talk about Q value. What is Q? Understand what is Q? What is Q? Q is the heat energy. Heat energy. Heat energy. So Q is energy. Keep that in mind. These are very famous types of question. They talk about Q now, they are talking about energy, right? So first two, they are talking about energy. Roman 3, what they are talking? Power of the heating coil. On now, power part is coming. Already they talked about energy, now they are talking about power. Hurry. What is the time taken to heat the water in the kettle from 20 to 100? Lamai, already they have talked about energy. Now they are talking about power and time. Now think and tell me what's the equation thing. Already they talked about energy. Now they are talking about power and time. Now what's the next equation you are going to apply? Energy equal power into time. Energy is equal to PT. That equation should come into mind. That's how these questions get connected. These are famous types of questions. First they talk about Q. Q is energy. Then they talk about power. Power and time. Without energy equal power into time. Right. What are they asking? Power of the heating coil in the to use to heat the kettle is 1000 watt. Power is given. What's the time taken to heat the water in the kettle? Water in the kettle. Water will take a certain amount of energy. We already calculated it. It takes a certain amount of energy. I take EW. And kettle takes a certain amount of energy. I write as EK. Kettle takes a certain amount of energy. They're asking what's the total energy, total time taken. Right. We'll apply the equation. We'll apply the equation. Third question. Energy is equal to power into time. They're asking the time, subject time is equal to energy divided by power. Energy. What is the energy value? Energy is the Q we calculated, right? What is the energy used to heat up water? 336,000 joules. This is the energy for water. What is the energy used to heat up the kettle? What is the energy for kettle? 12,800 joules. This is the energy for kettle. Now, what do you write as E here? What do you write as E here? It is EW the EK the natham both EW plus EK the. EW the EK the natham both EW and EK the. Both EW and EK. Why? Heating coil is heating both the kettle and the water. So the time taken to apply that power should be used for the full energy there, EK plus water. So energy is EK plus water. I'll write it and start. EK plus what? I'll write EW plus what? EW plus EK divide by power. What is EW? 336,000 joules plus. What is the EK value? 12,800 joules divide by what is the power? 1000 watt. If you do the math there, you can calculate the time. How much? If you add it first of all, 0, 0, 8, 8, 4, 3 divide by 1000. 348.8 seconds. Sorry. If you want, you can keep it in minutes as well. You convert to minutes. Understand why we got EW plus EK. If you want, I'll write it and keep. That's the total energy. Total energy divided by power. Those are places where you can make mistakes. Sometimes you will write only EW value. Sometimes if you will write only EK value, then you'll get wrong. You'll get wrong. Alright. Roman 4. The following measures have been taken to prevent the loss of heat from the kettle to the outer environment. A. Closing the kettle. B. Polishing. State the method of heat transfer controlled by each of the above. Closing the kettle with a lid. You're putting something on top. If you put something on top, what you will control? Convection. Something on top will control convection. Polishing. Polishing will control radiation. Alright. So conduction. Tell me conduction. Conduction take place where? Only on solid. Can you discuss about a solid part here? Closing the kettle with a lid. Does it control conduction? No. If they talk about using a plastic lid, using an insulated lid, then you can talk about conduction control. Nah, they are just telling closing the kettle with a lid. So lid is something put on top. When you put something on top, the air on top of the kettle getting heated and going out due to convection is controlled. So that air keeps on circulating inside. So convection is controlled by putting a lid. Something on top will control the convection. B. Polishing the outer surface. Polishing the outer surface will control the radiation. Polishing will however control radiation. Next, 2019. Neither. Right. Again, see. Geometrical optics. Lenses part is discussed. Second part. Power. Power question. Energy power. Here voltage power. That question. Hurry. Will work. 7A. This 2019. 2019. 7A. Figure Roman 1 below illustrates how a ray of light coming parallel to the principal axis of a glass convex lens travels after refraction. Convex lens. Light ray coming parallel, refract and go through focal. In final seminar, I taught you all the simple shortcut for convex lens. Parallel goes through the focal. Hurry. The point A, B, C, D and E are marked on the principal axis of the lens so that AB equal BC equal CD equal DE. Name the point C and D. What is C? C is the optical center. C is the optical center. Optical center. D. What is D? D is the focal point. D is focal point. Another name for focal point is focus. Roman 2. Copy the figure 2 and 3 below in your answer script and complete the ray diagram. Light ray coming towards the optical center. No refraction, travels in the same path. Make sure you put the arrowhead. No arrowhead, you won't get marks. Next. Light ray coming through the focal. Light ray coming through the focal. Light ray coming through the focal. Refract and goes parallel. Draw a parallel light ray there. I don't know why when I write it doesn't get drawn there. It goes parallel there. Draw a parallel light ray. Roman 3. Consider the images formed of an object placed between the point A and B. Between A and B. Between A and B is between F and 2F. This is F. This is 2F. You are keeping an object between F and 2F. We'll talk about the properties of the images formed between F and 2F. We'll talk about the properties of the image formed between F and 2F. I taught you all shortcut for this. If an object is between F and 2F, if an object is between F and 2F, object between F and 2F, where is the image form? Image from away from the 2F, inverted enlarged image. That will be your image. Between F and 2F, image is from away from 2F. Image is from away from 2F. So what are the properties of this image? This is inverted image. It's a real image. It's an enlarged image. Those are the properties. You're asking two characteristics. You can write enlarged, inverted, real. Roman 4. Describe briefly an activity that could be done to find the focal length of the convex lens. They're asking activity to find the focal length of a convex lens. How to find the focal length of a convex lens? What kind of activity we can do to find out the focal length of a convex lens? Simple. You take a convex lens, show it to parallel beam of light. Now, how to find parallel beam of light? Think about the light coming from sun. Sun is very far away. Light ray coming from sun, now parallel beam of light. So you focus the convex lens towards parallel beam of light. You all tell me, when light rays are sent through, when parallel beam of light rays are sent through a convex lens, when parallel beam of light rays are sent through a convex lens, what will happen? When parallel beam of light rays are sent through a convex lens, what will happen? All those rays will refract and they will meet at a single point. They will meet at a single point. Meeting point is what you call as focal point. So at the meeting point, you will see a single spot of bright light. You will see a single spot of bright light. So what you can do is, you take a convex lens, focus it to sunlight, parallel beam of light come and direct that light towards a screen, adjust the convex lens until you get a single spot of bright light. After you get a single spot of bright light, measure the distance between the lens and the focal. That distance is the focal length. Focus a convex lens to parallel beam of light. Light ray refract and meet at a single point. So at that single point, you will see a single spot of bright light. Try to get this onto a screen. Measure the distance between the lens and the screen. That is your focal length. Right? So if you write it in sentence, you can write down. Place a convex lens. Place a convex lens. Focusing light rays from sun. Focusing light rays from sun. Focusing light rays from sun. And keep a screen in front. And keep a screen in front to obtain a single spot of bright light. To obtain a single spot of bright light. To obtain a single spot of bright light. Within brackets, you can write focal point. Within brackets, we can write focal point. Full stop, continue. The distance between the lens and the screen. The distance between the lens and the screen. Distance between the lens and the screen. At that moment is focal length. At that moment is focal length. Hurry, right. B part. Last question. A domestically used filament electric bulb is marked 240 volt, 60 watt. While an LED electric lamp lighting with an equal brightness to it is marked 240 volt, 10 watt. I'll write those data separately. Filament is 240, 60. LED is 240, 10. Filament 240 volt, 60 watt. LED voltage is the same, 240 volt. Power is different, 10 watt. All right. I wrote the data separately now. Roman 1. Calculate in joules the amount of electrical energy consumed if the filament electric lamp was switched on for 10 hours. They're talking about filament. Filament is working for 10 hours. Time is given. They're asking energy. What else we have? Power is there. What's the equation? Power equal energy times time. They are asking energy. Energy is equal to, what are they asking? නෑනේ මේ equation එකත් බැහැ. Power is given. They are asking the how much is the electric energy in joules consumed if 10 hours, right? Time is given. Power is given. They are asking energy. එහෙනම් ඉතින් that equation. Energy equal මේ මොනවද මේ? Energy equal power into time equal PT. Power is given 60 watt multiplied by time is 10 hours, it seems. 10 hours. Can I directly write it in hours to get the answer in joules? No. I have to convert it into seconds. How to convert it into seconds? 1 hour we know. 1 hour contains 3600 seconds. How? 60 into 60. නේද? 1 hour is 3600. එතකොට 10 hours 10 into 3600 seconds. හරි? 1 hour is 3600 seconds now. 10 hours is 10 into 3600 seconds. From there you get the energy value. 36 into 6. How much? 36 into 6. 2,160,000 joules. 2,160,000 joules. Don't convert to kilojoules because they are asking the answer in joules. No? So this question don't go to convert to kilojoules. Hurry. Hurry. Roman 2. How much is the electrical energy in joules consumed if LED lamp was switched on for 10 hours? Same how you do for LED. Same you do for an LED. Energy is equal to power into time. Power is 10 watt. Time for LED is again 10 hours. So same logic there. 1 hour is 3600. So 10 hours is 10 into 3600 seconds. If I do the math there, how much? 3, 6, 0, 360,000 joules. 36, 1, 2, 3, 4, 1, 2, 3, 4, yes. 360,000 joules. That is for LED, this is for filament bulb. Eh? I'll write EF, filament bulb. I'll write EL, LED bulb. Roman 3. From the above calculation, show that LED lamp is more advantage for domestic use. Harine lamai. Look at LED and the filament. Filament is 2,160,000 joules. LED is only consuming 360,000 joules. So which one is more efficient? LED is more efficient. So you can write electrical energy consumption in LED is less. Electrical energy consumption in LED is less. Electrical energy consumption in LED is less. Therefore, it is more advantage. Electrical energy consumption in LED is less. Therefore, it's more advantageous. Roman 4. The LED lamp mentioned above was lighted for 30 days, 10 hours each. Now, we calculated already for 10 hours. Like that, they are using containers for 30 days. Find in kilowatt hour amount of electrical energy supplied to the lamp during this period. 1 kilowatt hour is 3.6 into 10 to the power 6 joule, right? Now we know the energy in joule for 10 hours. 10 hours energy in joules we know for LED. Now they are telling like that it is working for 30 days. Like that it is working for 30 days. For 10 hours we know. This is for 10 hours. 10 hours we know the value. Now we'll calculate for 30 days. LED energy for 30 days. I'll write these things and calculate so it's easy for you to understand. Energy for 10 hours, 360,000 joules. 1 day it's working 10 hours. Ethokota 30 days, what's the energy? Right, energy of LED for 30 days. 10 hours this, 10 hours is for 1 day. So 1 day is this. So 30 days, 30 into 360,000 joules. That is 1,080,000 joules. That's not the answer. This is in joules. They are asking in what? They are asking in what? Kilowatt hour. Can you remember we did same type of question? 1 kilowatt hour this much. Same type. So 1 kilowatt, they are given in hint. 1 kilowatt hour is 3.6 into 10 to the power 6 joule. I thought this is how much. This is how much. I'll just write the base. You'll start doing this. Make a final answer. I want already we did this kind of a question. 1 kilowatt hour 3.6 into 10 to the power 6 joule. එහෙනම් how much of kilowatt hour? How much of kilowatt hour? I'll write as E. How much of kilowatt hour is 1,080,000 joules? 1,080,000 joules. 1,080,000 joules in scientific notation, if I write 1.08 into 10 to the power 1, 2, 3, 4, 5, 6. 10 to the power 60. Ned? Check whether my scientific notation is correct. 1.08. After keeping point, how many digits are there? 1, 2, 3, 4, 5, 6. So 10 to the power 6. How you apply? Divide this. 1 kilowatt hour is divided by E is equal to 3.6 into 10 to the power 6 divided by 1.08 into 10 to the power 6. Now subjecting you should properly do E take on top, E goes up. 1.08 goes up, 3.6 goes down. So E is equal to 1.08 goes up into 10 to the power 6. 3.6 goes down. 10 to the power 6, 10 to the power 6 cancel off. 1.08 divided by 3.6. 1.08 divided by 3.6. 3 ಇದು 0.03 ಇದು 3, 4, 1, 2, 3, 4, 5. චූටි mistake is made. මෙතන 0 එකක් වැරදිලා නේද ළමයි? 1, 2, 3, 4, 5. 5 zeros. 1, 2, 3, 4. Only 4 zeros I have added. So there 1 0 is missing. 1 0 is missing. So it is 1, 0, 8. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 joule cell. Which means this is 10 to the power 7. This is 10 to the power 7. 1, 2, 3, 4, 5, 6, 7. 10 to the power 7. Which is, this is also 10 to the power 7. This is also 10 to the power 7. Now do the math and see. Our part do the correction. Now do the math and see. You'll find out the answer. What's the answer? 10 to the power 6, 10 to the power 7 cancel off, but still 10 will be remaining. 10 will be remaining. So that is 3.6 divided by that is 3.6 divided by 10.8. That becomes on the other side 10.8 divided by 3.6. 10.8 divided by 3.6 is 3 kilowatt hour. Recheck the mathematical part one more time. Harani? 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, 3, 4, 5. Hurry. 3.10 to the power 6. 1.08. 1, 2, 3, 4, 5, 6, 7. 100 to the power 1. Hurry. Then hurry. What are the got? 3.6 10 to the power 6. 1.08. Method what the got? 10 to the power 7. This should be 10 to the power 7, 1.08 into 10 to the power 7. This one 3.6 into 10 to the power 6. Now these two cancel off. 10. 10.8 divided by 3.6. Hurry. 10.8 divided by 3.6, you will get 3. Hurry. Is that the last question? Nah. One more question is there. Of the electrical energy supplied to the filament electric lamp, 40% is lost as heat. In that case, what is the efficiency of the lamp? Now, in an electric appliance, you are supplying 100% of energy. Out of that, 40% is lost. If 40% is lost, what is the useful energy you are getting as output? Out of 100, 40 is lost. Now, how much is coming out as useful output? Only 60%. A efficiency. Efficiency is 60%. Okay. Okay. Right. This question again, recheck the zeros and you all properly write it and give. Any doubts up to there? So remember your seventh question, seventh essay, physics question, usually it comes from optics can come, energy part can come, Q equals MC theta part. That can get connected into the power part. Power section can come, this kind of power section. Be careful in the maths part. Power section can come. Recent question, they are adding linear motion as well. Linear motion can come, right? Those things can come. I think if it is like 2024 paper, only 20 marks, you can fully score. Or a distance displacement. If that kind of a question come, surely you can score the full marks. That kind of question. If you get that kind of question, anyone select it and do it, you can get your full score there. Doubtlessly, you will have your full score, full 20 marks. You can get it from there. Next, now we have come to the 6-day count. 12 past need. Yes, 12 past. We have come to the final 6-day count. Now don't even think of giving up this final few meters of the race. Keep the focus in the brain, keep the focus in your mind. Work with a purpose. No terms and conditions here. You give your best. That's it. You give your best in the remaining 6 days. Whatever that has gone is gone. That you can't change now. That you can't go reverse and change your time and again start working what is there behind. No, you can't do that. What is remaining? Another 6 days. In these 6 days, yes, a drastic change you can do to your full result. A big change you can do. Don't believe on some people who are telling in 6 days you can't work and get a proper result. And still I'm telling with responsibility, with 6 days you can make a big drastic change to your full final result. That you do now. Final 6 days now. Don't keep thinking on whatever that has happened. Don't allow your stress or your depression or your fear or your feelings to control you. Your heart, your heart or the feeling should not control yourself. Your brain should control yourself. Give priority to your brain. Work according to what brain tells you. Keep the focus inside you. Keep running. Now all of you can. You all are working now, which means you all can. That is why you are on to this. Don't finish it with a normal result. Go for your best result. Finish it and keep working after that as well. Hari. Hari. Ehenang. With that, I will finish our sixth essay, seventh essay question. Hari neda. Hari. Keep working. Good night.